Now the question is, a toy train is moving along x-axis in such a way that its coordinate x varies with the time t. According to the expression x equals to 2 minus 5t plus 6t square plus 9t cube, where x is in meters and t is in seconds. What is the initial velocity and acceleration of the toy train? So it is very interesting, right? Whatever have the we have given, just let us find it, what we get it. So x, what is along x direction it is moving, means you can imagine that it is happening one dimensional. Along the x axis the body is moving, train is moving, right? Train is moving along x axis, along x axis means it is one dimension we can imagine. Then x, that expression is what given, x equals to 2 minus 5t plus 6t square plus 9t cube is given, and whatever the terms already explained, but initial velocity is asked. What is the velocity? Velocity u equals to dx by dt I can find, dx by dt I can find. Then dx by dt means d by dt of x value. What is the displacement function given? 2 minus 5t plus 6t square plus 9t cube, 9t cube. So already repeatedly whatever we are going to get here is d by dx of x to the power of n. That means n into x to the power of n minus 1, because here it is that t to the power of 1 is there, t to the power of 2 is there, t to the power of 3 is there. So that's why everywhere we are going to use the same formula repeatedly. We are going to apply it. So then what? And constant value, d by dx of any constant value is there, what you will get? 0 you will get, because the slope, if constant is there, slope is not there. That's why d by dx of constant is going to be 0. Now let us do that. What will come? Separately I am writing it because it is additional rule. Each term you can separate. How many terms are there? 1, 2, 3, 4 are there. So we can write separately. What is that? Each one, d by dt of 2 minus d by dt of 5t, and another one plus d by dt of 6t square plus d by dt of 9t cube, 9t cube. And another formula what we are using, d by dx of some constant into f of x is there. What you will write? Constant outside and d by dt of, or d by dx of f to the fx, that function you will write. In that term we have another. So by the combination of these formulas repeatedly here, we are going to get d by dt of constant value is 0 minus, here you are going to get 5 only, 5 into d by dt of t. So what you are going to get? 1 only. So plus 6 into d by dt of t square means n into x to the power of n minus 1. If you apply it, 2 into t 2 minus 1 will come, plus 9 into 3 and t square will come, because 3 minus 2. So if you apply that, what you are going to get? Minus 5 is there, plus 12t, so plus is there, 27 t square is there. What is this? This is the u value. It is representing velocity, velocity, right? This is the velocity term. And these, if you know the after what seconds it is asked, if you know, you can find that value exactly in numericals, in numbers. Meters per second, it is a unit, right? So if it is the initial velocity, what will happen? T is going to be 0, because the train has started at the time t equals 0 seconds, means at that time whatever the train has a velocity, that is going to be called as a initial velocity. After some time, the train is having the some velocity, that is going to be the final velocity. That's why I'm writing here it is a u only. But is it initial velocity? No, because t is not taken as a 0. That's why I am writing this as a v. It is writing as a v. That's why it is generally it is written as v. But if it is a initial, t has to be substituted as 0. And what about another one? Acceleration is asked. What is the acceleration? Again, dv by dt. dv by dt. That means d by dt of rate of change of velocity. If there is a rate of change, definitely we have to use the differentiation, right? So that one is minus 5 plus 12t plus 27t square. Then if we apply that, if we expand it, I will write it separately, d by dt of minus 5 plus d by dt of 12t plus d by dt of 27t square. So again, whatever the formula is written above, right, the same are going to be used here. Then d by dt of constant is going to be 0. d by dt of 12t, it is going to be just 12. And whatever this, plus 27 into 2. 27 into 2. It is a 54, 54t will come. So then acceleration is this. Acceleration is this. Right. So these are the values how we get, and we got the answer in terms of equations only. In terms of equations only. Still we don't have any numericals. Why? Because the time is not mentioned, just time is said as only t. That's why that is equation we are writing as acceleration in meters per second square. That's why we are getting like. And what about if values is given? Suppose if after t equals to 3 seconds or at 3 seconds, wherever t is there, you substitute to 3, you will get velocity at the 3 seconds, acceleration at 3 seconds. That's all. If you want at 10 seconds, what you can get? In case of t, you substitute 10. Whenever you substitute in a v equation, you will get velocity. Another second equation is there for acceleration. If you substitute that time equals to 10 seconds, you will get acceleration at that 10 seconds. Like this we can solve. And I think you understand why we are applying here the differentiation, right?